Welcome to our deeply insightful video titled, Scientists Predicting and Battling Extreme Weather. In this riveting expose, we will take you behind the scenes to explore how cutting-edge technology, artificial intelligence, and collaborative global efforts are helping scientists to predict and combat the toughest weather conditions. You'll discover how satellites monitor global climate changes, how supercomputers are aiding in weather predictions, and even how we're using cloud seeding technology in the battle against drought. Stay tuned for a breathtaking journey into the science behind weather forecasting. You definitely don't want to miss this. 1. AI and machine learning revolutionize weather forecasting in recent years. The advancement of AI and machine learning has transformed weather prediction methods. These cutting-edge technologies process massive amounts of data at unprecedented speeds, leading to quick and precise forecasts of extreme weather events. It's fascinating to see how companies like IBM and Google's DeepMind harness AI power to enhance meteorological capabilities. Think of AI in weather forecasting as a skilled detective, piecing together clues from scattered data to provide a clear picture of the future. This technological leap aids in predicting hurricanes, floods, and even heat waves, allowing communities to brace themselves for natural disasters. 2. Satellites monitor climate in real time. Humanity has witnessed a revolution in satellite technology, which plays a crucial role in real-time climate monitoring. Over 3,000 satellites observe Earth, offering invaluable data on changing weather patterns and environmental conditions. For instance, the GOES-R series satellites are strategically placed to monitor lightning, aiding in the anticipation of severe storms and tornadoes. Imagine these satellites as celestial sentinels, perpetually watching over our planet, sending vital signals to predict hazardous weather dynamics. The ability to detect storms and droughts swiftly empowers meteorologists to devise strategies, ultimately saving lives and reducing damage. 3. Hurricane intensity is harder to predict. Predicting hurricanes remains an intricate challenge for scientists, not because we can't track where they're headed, but because their potential force is often elusive. The interplay between ocean currents and atmospheric conditions significantly impacts hurricane intensity. Researchers have begun deploying underwater drones to harness real-time ocean data to tackle this complexity. Picture these drones as intrepid explorers, delving into oceanic depths to retrieve hidden clues about hurricane behavior. Although technology tracks hurricanes accurately, predicting their intensity requires a nuanced understanding of our dynamic planet. 4. Supercomputers simulate climate scenarios. Supercomputers are workhorses of modern climate science, replicating extreme weather scenarios to aid decision-making. Machines like Japan's Fugaku can quickly simulate complex climate models, offering governments crucial insights into potential futures. These simulations engage in a kind of virtual time travel, projecting various outcomes based on present data. They test the efficacy of possible mitigation strategies, paving the way for better prepared responses to natural disasters. Supercomputers provide a safe platform for scientists and policymakers to conjure up what-if scenarios, helping us face tomorrow's challenges today through detailed analyses. 5. Scientists track heat waves with wet bulb temperature. Monitoring heat waves today involves more than just checking thermometers. Scientists have begun utilizing a metric known as the wet bulb temperature to assess combined heat and humidity levels. When this index rises above 35 degrees Celsius, 95 degrees Fahrenheit, survival becomes tenuous even with full hydration and shaded conditions, highlighting the lethal potential of heat waves. Think of the wet bulb temperature as a harsh warning sign, indicating the unsustainable climatic extremes that are becoming more common. Understanding this measure is akin to learning the language of nature, which communicates clear threats through temperature fluctuations. 6. Cloud seeding as a weapon against drought. Cloud seeding emerges as a fascinating approach to combating drought. By placing particles like silver iodide into the atmosphere, scientists can stimulate rain production in otherwise arid conditions. Countries like the UAE and China lead this endeavor, viewing cloud seeding as a strategic tool. Imagine cloud seeding as a form of human experiment with nature, where weather manipulation seeks to replenish parched lands. While this approach holds immense potential, it also opens discussions on ecological effects and ethical considerations, balancing the quest for rainfall with responsible stewardship. 7. Warning systems save lives in a world plagued by unpredictable weather patterns. Advanced warning systems stand as sentinels against catastrophe. Countries like Japan and the Philippines have created intricate networks informing residents of typhoons, tsunamis, and other extreme events. These systems combine seismic sensors, weather radars, and sophisticated predictive technologies. Early warnings grant communities precious time to evacuate or, at the very least, seek safety. Imagine living with an early warning system as a silent guardian, alerting you before chaos, and affording you a fighting chance against nature's fiercest displays. 8. Climate change makes weather models evolve. The ever-present specter of climate change forces meteorologists to reshape traditional weather models. Predictors must now account for rising sea levels, altered jet streams, and warmer oceans. These elements transform once predictable patterns into intricate enigmas, demanding constant recalibration. Envision these evolved models as constantly evolving maps, charting the paths of more capricious natural phenomena. As climate change throws wrenches into past understanding, scientists must refine tools to distinguish their complex effects, supporting humanity's resilience amid perceptible alteration. 9. Lightning detectors in space. As thunderheads swirl above, NASA's Lightning Imaging Sensor, LIGO, on satellites detects lightning strikes on a global scale. This invaluable data aids in forecasting storm severity, especially in regions where terrestrial sensors are sparse. Think of these detectors as celestial symphonies that capture the crackling tune of lightning, composing a detailed picture of atmospheric unrest. The ability to identify lightning activity from space plays a crucial role in dissecting storm characteristics, urging preparations long before ominous rain clouds hover overhead and manifest their fury. 10. Global collaboration drives research. International cooperation is the keystone of understanding and confronting extreme weather phenomena. Spearheading efforts like the World Meteorological Organization, WMO, which promotes synergistic collaborations among nations, integrates scientific research with policymaking. Their Global Framework for Climate Services, GFCS, merges knowledge and strategy, enhancing global preparedness for weather cataclysms. In a world where nature shows no respect for borders, collaboration becomes necessity, not option. When countries unite, they fortify their defenses, apply the most current scientific insights, and safeguard a shared future against the might of unrestrained weather extremes.